So on behalf of the International Space University and the University of South Australia, I'd like to welcome you to tonight's panel, Using Satellites to Overcome the Digital Divide. So firstly, I'd like to thank NewSat, who are our public event partner. And I would also like to thank our other participants for coming. We have David Ball from NewSat. Then we have Matt Dawson from NBNCo, the real NBNCo. As you know, this afternoon we had a company that sounded like NBNCo in one of our activities, but wasn't actually NBNCo. And also Leake from Optus. So as I was preparing for tonight's panel, I began thinking a little bit about what is the digital divide, and I found some definitions. The main one being that it's inequality between groups in terms of access to and use of information and communication technologies. So it can be inequalities between individuals, businesses and geographic areas. So, and I guess what people consider is that technology can provide all sorts of benefits. So these could be social benefits such as literacy. Of course, a favourite of ours may be entertainment, and also commercial benefits. So there was actually something I wanted to share with you as well. When I was a student here in Adelaide in 2004, we undertook a project that looked at these sorts of concerns, social concerns, economic, and we did a bit of analysis, and we happened to come up with our own solution for how to bridge the digital divide in Australia, and it happened to include a 2 Ka band solution. So perhaps it's a little bit similar now to what NBNCo are doing for real. So we'll be checking up later whether that was our report that got you started. But each of our 3 speakers tonight are going to give their perspectives on bridging the digital divide using satellites. So I'm just going to introduce each speaker, and then they'll give their presentations. And I'll ask you to save questions for the end. So our first speaker, Mr. David Ball, has 25 years of experience in the telecommunications, media and technology sectors, with a significant portion of his career specialising in satellite communications. He has held senior positions encompassing sales team management, product development, engineering and space systems development. Prior to joining NewSat, he was the Regional Vice President Asia Pacific for Intelsat, and also held that position for PanAmSat prior to their merger. More recently, David was the Managing Director for Intelsat Broadband, a subsidiary of Intelsat Corporation. He holds a Bachelor of Engineering degree from the Royal Melbourne Institute of Technology and a graduate diploma in Business Management from Deakin. Prior to joining PanAmSat, he served as a commissioned officer in the Royal Australian Air Force, specialising in communication systems management. He joined NewSat in 2011 and has been instrumental in the strategy and development of the Jabiru satellite program's first satellite, Jabiru-1, which will deliver high-powered Ka-band coverage across the Middle East, Africa and Asia. Please welcome David.
Thank you, Alex. That bio makes me sound kind of old, but we won't get into that at the moment. Ladies and gentlemen, welcome to the evening. It's NewSat's great privilege to be able to sponsor this evening, and I hope you enjoy the presentations. And I wanted to start off with NewSat's presentation, looking at how we view overcoming the digital divide. So in terms of the agenda, I wanted to run through looking at NewSat's overview of what NewSat is, who NewSat is today, overview on satellite communications generally, and looking at a specific example of disaster communications. That's a real example of where a digital divide occurs through man-made incident or natural incident, that we need to look at how to solve that communications problem. In terms of NewSat, many of you may not have heard of NewSat. We're an emerging company specialising in global satellite communications, providing tailored teleport and VSAT services for 75% of the Earth's surface. We look at focusing on providing services to remote areas and temporary sites. Looking at providing communications anywhere, anytime is really our mantra. Our vision is to become a global satellite operator. Today we're a satellite services provider using our teleport facilities here in Adelaide and also in Perth, leveraging other people's capacity, other satellite operators' capacity to provide managed service solutions to our client base. And one of the challenges we've seen is with the increasing appetite for bandwidth that users have, is that we're finding it difficult to get capacity in the right places with the right connectivity, in C-band or in KU band. So we've made the decision to invest in our own global network to take control of our supply chain and give our customers the growth that they're looking for their capacity. So I mentioned our two teleports, one here in Mawson Lakes, quite close to here, 11 antennas, uplinking to satellites in C and KU band, providing a number of services from here to the Middle East and around Australia. Also our Perth teleport with more focus on the resources sector from Perth, also connecting to about 9 satellites, also in C and KU band from Western Australia. Of course, all the facilities are 24/7 operations. We have mission-critical applications for our clients, and we need to ensure that we have a total uptime with those. I've talked about the Jabiru program. That's our Ka band network of satellites which we are building. The first satellite, Jabiru 1, is under construction at the moment at Lockheed Martin. We have booked the launch vehicle with Ariane to launch the satellite. So we have very excited about that program for us, and of course we are looking at further satellites beyond that, which we'll announce in the coming months. So our real focus here is to look at that new capacity where we have customer demand in regions where there's huge growth taking place. The appetite exceeds the available capacity. We're looking at how to increase the supply. C-band is becoming congested. There's C-band encroachment from terrestrial services. KU band, similarly so, is saturated in many of the regions we're looking at. There's no more orbital arc and orbital filings available. I know the ISU students have been through the whole ITU lectures. We've looked at the 2-degree arc spacing. We are out of capacity at KU, so the next place the industry is going to is KA. And that's really driven by the success of the broadband residential internet services, which have brought down the cost of the RF equipment. It's now freely available, and we are seeing a lot of work done on modem technology to make that a very workable technology for customers. But talking about satellites generally, I think all 3 panel presenters tonight will focus on the geostationary orbit. That's the orbit that's 36,000 kilometres above the Earth. So a satellite in that orbit will rotate at the same speed the Earth does. So from a user on the Earth will see that remain in effect stationary. That allows the industry to use simple, small, low-cost dishes to do services. There's other orbits there which I'm not going to focus on in my presentation, medium Earth orbit and low Earth orbit dishes, which are used for different applications. GPS satellites, for example, are in medium Earth orbit. When you turn your GPS receiver on, you probably look at the number of satellites it's receiving at any one time, number of satellites it can see. They're constantly moving in a constellation. Low Earth orbit used for Earth observation, surveillance satellites and so forth. So the focus of tonight will be on geostationary orbit. And this is a geostationary arc that I talked about earlier, where we see all the satellites filed in C, KU, Ka band. It's very congested. If you look at that arc, you've got to be on the equator at 36,000 kilometres. Tremendous amount of filings going on, a lot of activity there, a lot of congestion. New spectrum is the core of the day. So generally, why do satellites matter to a user? Why would people use a satellite compared to using fibre? You know, communication satellites today are an essential part of the infrastructure around the world, carrying media content globally for special events, for distribution, the services you see on Foxtel, coming into Australia on satellite, coming to you in your house, often on satellite, if not on the cable network. Satellites are used in so many different ways that you don't see every day, but you know you'd miss it if it wasn't there. So linking businesses that are widely diverse and network restoration, which I'll talk about later in the presentation. So the advantage of satellites is once you've launched one, you have full coverage area from day one. You don't have to wait for the guy to come along, digging the trench, laying the fibre, laying the terrestrial network. You can implement a service straight away, a distance independent from the hub station. You can be other side of the country from the hub station, you can be next door to the hub station. The satellite doesn't care. So it's very quick to deploy infrastructure, and this gets to that disaster theme I talked about, where terrestrial infrastructure is destroyed or diminished due to a natural disaster. That's where satellites can step in and become that instant replacement. Satellites are great for broadcast. I've talked about direct-to-home services such as Foxtel, where you're taking one uplink and broadcasting that same content to hundreds of thousands, tens of thousands of homes. That's a perfect application for a satellite as a broadcast technology. For communications, we're looking at connecting the unconnected. You're not going to use a satellite to link between London and New York today. 20, 25 years ago you did do video interchange on satellite between those two cities. Today there's fibre between those cities. You wouldn't think of using satellite to do a broadcast. For remote users, one to the middle of nowhere. So you're looking at remote platforms, remote users who really have a need to get content. And satellites are perfect for thin route applications that grow over time. Often users, commercial users that we deal with, don't know what their needs are going to be over time. So they start with a 512 service, they might end up to a megabit and 2 megabits. Satellites are very scalable like that. With a fibre link, you've got to put a fibre in, fixed capital costs, and you can't scale it very easily. Satellites also allow for asymmetric services. You can put more service forward to the user in a remote area. They may want to pull more data in than they need to send out. Or indeed, in the case of many of our mining companies, the opposite is true. They're pushing a lot of geological survey data back to the headquarters to be processed. And the great thing about satellites is you can easily reconfigure that on the fly. You don't have to change the network totally. You move the earth station, start up a new service. An example here of industries and verticals that we focus on. At NewSat, oil mining and gas is a big one for us for our resources sector in Australia. We're also very focused on supporting defence applications and government services through Adelaide and Perth. I want to talk today a little bit about disaster recovery, so I know we're going to run out of time if I'm not careful. So talking about disasters, so what happens to a communications infrastructure? You see you've got a very well entrenched terrestrial network, you've got great cell towers, you've got terrestrial services, so straight away that's destroyed. Earthquake, fire, we've seen a lot of recent issues are in many states around Australia with the bushfires, a lot of devastation taking place. So cell towers get burnt out and destroyed, the terrestrial copper network gets destroyed. International services, in the case of tsunami, which I'll talk about the Japanese tsunami as an example a little bit, that's where things get really affected. So that's where satellites can step in, fly in equipment, drop equipment in, the day after a scenario, they re-establish communications and get that communication re-established. Of course, one of the biggest consumers there is the media services, to get coverage of the event, to let people know what's happening to people in their homeland or whatever. So applications change over time. So satellite phones become an initial lifeline to get service re-established. Remember, the cell phone network's gone. There's no connection there. News organisations are rushing in to get content out. We often look to put services on trailers, bring them in using satellite dishes to get cell phones re-established. And situational awareness is a very big one for the command and control, for the guys on the ground to know what's happening in the area, to know what resources need to be brought into a disaster scenario. Then a sequence of events. Obviously you don't predict a disaster, so you've got disaster warnings occur. So you've got an earthquake occurs, or you see a tsunami coming, or bushfire alerts. Evacuate when you can. When a disaster strikes, the emphasis is on getting first responders in to assess and assist. Search and rescue teams to find remaining casualties. And then you get into disaster assessment, getting more and more people coming in, more communications grows over time. For the first 4 to 24 hours, we are focused on just getting inventory, knowing the scale of the disaster, knowing what's required. You're looking at handheld phones, then you're looking at bringing flyaways in, 24 to 48 hours after the event. The biggest issue that was experienced in Indonesia when the tsunami hit up there was the ability to get communications infrastructure back into those areas, because there's so much demand on air transport, to get services in and out. You've got to have small equipment, easily transportable, easily operated by skilled and semi-skilled operators. You don't always have a technician to be available to send into a disaster area. And in the recovery phase, 5 to 10 days and onwards, you're looking at more established infrastructure being able to be brought into a disaster area. The communications bandwidth requirement grows over time. Initially it's voice calls, some small data, then larger data pipes, and you're looking at replacing telephone exchanges, telephone infrastructure. There's a moving feast as you go through. Looking at Japan, the tsunami there I think was unprecedented for a developed country in terms of the damage that took place. The total devastation on the power system, transport, communications, housing on a massive scale. So of course satellite came in to assist there to help. Getting fibres internationally in and out of Japan were destroyed and damaged. So international capacity was gone as well as domestic. It's interesting as you think through what was done in Japan. A very good example I use is IP Star as a company in Thailand who provides a broadband service for customers, and Japan was one of their markets, and it was a very well-established market for them, focusing on putting dishes on people's houses, bringing broadband to remote areas of Japan. One thing IP Star had never thought of, or their service provider in Japan had never thought of, is what happens when there's no power? All the IP Star terminals relied upon mains power to work, and there wasn't any. IP Star had developed terminals for third world emerging nations which worked off car batteries. None of those are in Japan. So as quickly as they could, getting 12-volt DC powered equipment to work off car batteries, hung up on whatever they could find to get that communications re-established. So it's interesting looking at, you think you're prepared for a disaster, but where's the power going to come from? How do you get that change in infrastructure coming through? The bushfires are another example. 2009 was the worst loss of life in Victoria. Of course, unfortunately, we've had a number of devastating fires this year. In that example back in 2009, a huge number of deaths and a huge amount of devastation in Victoria. Fibre was damaged, cable was gone, ADSL was gone, wireless was gone, cell phones were gone. So something that many service providers worked on, NewSat worked on that, I know Optus did, I know Telstra did, to get services re-established as quickly as possible. Because people want to find out if their loved ones are okay, let people know they're okay, re-establish communications, get their banking done, get the routine business back, getting back to life on board. It takes a long time to re-establish terrestrial infrastructure. So satellites are able to leapfrog that development, get initial capabilities in, and get things back working again. And with that, I'll end my presentation. I'd like to thank you again for coming along tonight, and hope you enjoy the evening. Thank you.
So now I'd like to introduce Matt Dawson from NBNCo. So Matt has 25 years experience with some of the country's largest, most complex and successful full-scale engineering development projects. And his engineering career commenced at the Aeronautical Research Laboratories, working on a variety of projects ranging from helicopter tracking systems, tactical terrain following radars, jet pilot heart monitoring systems, and the F-111s. At Aerospace Technologies of Australia, Matt, as part of a small team of engineers, successfully developed the NULCA, you can correct me later on all the acronyms that I get wrong, a hovering rocket active decoy against the Exocet missile, and considered Australia's most successful Australian-American collaborative defence program. He also worked on the Jindavik program, and that being a jet-propelled unmanned automated vehicle, or UAV, used by the Royal Defence Forces of both the UK and Australia. His corporate experience broadened during the 90s. He was a senior consultant at Price Waterhouse Urich, and he re-engineered factory processes and plant layouts in the automotive and plastics manufacturing industry, achieving significant quality and cost improvements. At Telstra Applied Technologies, he managed the delivery of the antenna systems component of the nation's drawn over-the-horizon radar network, before being given the challenge of directing the Engineering Development Program Commission, which was a new mission-critical, state-of-the-art air-ground-air voice and high-frequency data communication network for the RAF across Australasia. Matt spent time at Advantra as the executive responsible for some of the country's largest IT and network services programs, before being a founding partner in the consulting firm IPI, specialising in managing large technology programs for clients like BH Billiton, ANZ, Telstra and others. After the rapid growth of IPI and its subsequent acquisition by SMS Management and Technology, he became the Group General Manager of Tabcorp's Information Technology Infrastructure and Operations, where he oversaw the successful national network technology migration for the group. He has now accepted the challenges associated with the nation's largest technology infrastructure program, building the national broadband network, as NBNCo's Program Director of Satellites. He's also the proud father of 2 teenage daughters and husband to a very busy wife, and he's an accomplished violinist, pilot, black belt in Taekwondo, so don't mess with him, skier and very frustrated St Kilda football supporter. Please welcome Matt.
Thanks very much. Wow, after that I too feel very old, and I've had far too much fun with a lot of projects, more than my fair share maybe. But thank you to the University of South Australia and the Southern Hemisphere Summer Space Program for inviting me along to speak tonight, and to address what we at NBNCo think is an important issue. Obviously, is overcoming the digital divide. 5 things I want to talk about this evening, really quickly, as quickly as I can anyway, give you an overview of NBNCo and what we are and what we're doing. And secondly, the technology types that we're using to provide the national broadband network with. The increasing demand, of course, for broadband capacity, and I'll start to use that as sort of to define what the digital divide as we see it is. And then fourthly, how NBNCo Satellite Solutions is addressing that digital divide. And then I'll get into some little bit of detail on the NBNCo Satellite Solution itself, our plan and our next steps. So, who is NBNCo? Well, the first thing to say here is that we're a company. We're not a government department like ACMA or Department of Human Services. We are a government business enterprise. The key difference, I guess, between NBNCo and any listed company is that we only have one shareholder at the moment, and that's the federal government, of course. But otherwise, all the normal governance arrangements that apply to any company exist for us as well. We have a board of directors and a CEO, and other government arrangements. So we therefore have to make commercial decisions, the same as any other commercial enterprise would. And of course, because of the public interest and because of the public funds being invested in the National Broadband Network, we're subject to an enormous amount of scrutiny. So everything we do very, very prudently and diligently, of course. NBNCo is wholesale only, offering uniform national pricing. So what does uniform national pricing mean? Well, we're not just wholesale, we're an open and equal access wholesaler, meaning that, of course, we offer the same products, the same services, the same price, under the same terms to any telco provider who then on-sells wholesale or retail services, independent of their size or scale. So from some of the largest telecommunications providers down to some of the niche players, all buy services from us on equal terms. So to be clear, there's no discount models applied here. It's equal and open access. And moreover, the basic common product that we sell is the 12 meg 1 product at the wholesale level. Across, so we sell that across all the technology types, irrespective of what technology is delivering that product. That's sold at the same price wholesale to the retail service providers. And so that's an important point when we talk about the digital divide, because that means that under that sort of model, the people in the city should be paying the same sorts of prices for that similar service. So that, so pricing is an important part of closing that digital divide between what people in the city enjoy and what people in regional Australia enjoy. So what does NBNCo do? Well, obviously we're designing, building and operating a high-speed broadband network connecting all Australians. And I think the key point there is the words all Australians, and that's obviously why we need different technology types to be able to build a truly national broadband network. We wouldn't be able to build a national network without using different technologies. We'd only be able to build, an East Coast network or something. So, and how we're doing it, as I said, we're using fibre to target 93% of the premises with a minimum obligation to our shareholder of 90%. And the remainder we're doing with a combination of fixed, wireless and satellite. And obviously this is a 10-year project. It's not something you can build. You can't build satellites overnight. You certainly can't build a national broadband network overnight either. It's certainly going to be a significant project and employ obviously 16,000 people nationally. That's not the number of NBNCo employees. That's the number involved in the construction activities and everything else as well. So moving on to this slide's really trying to show that as an operator, a wholesale operator rather, our job is to take layer 2 bits so people understand, I assume people understand what I'm talking about when I say layer 2. We shuffle the bits from the premises, people's homes, schools, hospitals or whatever, and we hand them off to the retail service providers. They're what we call our points of interconnect there. That's the dot on the juncture there. There are 121 points of interconnect across the country, and each POI serves a customer serving area of between 50 to 150,000 premises. So retail service providers connect to our points of interconnect, and they can sell services or access to those services, the 50,000 to 150,000 premises, using any of those technologies. They connect using the same interfaces, it's the same processes, it's the same product construct, it's the same pricing. The retail service providers don't have to worry about the technology infrastructure that's delivering those bits, bits and bytes, Ethernet layer to those point of interconnects. So if you think about it, that's fairly industry changing compared to how it works in Australia today. So NBNCo, it's not just about the technology, it's not just building a network, of course, it's the changing the industry as we know it at the moment as well. Some of the barriers to entry, people don't have to worry, access seekers don't have to worry about the infrastructure that's providing those bits and bytes to the points of interconnect. We're trying to occupy, the smallest footprint of value add, I guess, in the overall value chain. Where the competition and where the value add needs to be is at the retail end of the value chain, and that's what this model brings about. And that's what we're occupying, the smallest part, or we think we are anyway. What this slide's trying to show is the percentage of the population covered by each technology. So what you can see there with the red dots is obviously the fibre. That's the fibre optic serving obviously the metropolitan areas, but you can see red dots there also serving a lot of the regional centres and towns as well. What the blue lines are is what we call our transit or our core network. So while we're building the fibre rolling down the streets and connecting up all the homes, we also need to in parallel connect the whole network together and bring all that data back to those points of interconnect and hand it off to the retail service providers, and that's obviously the services that you buy, the plans that you sign up to is through the retail service providers. So if I click again, outside of the red dots you can see now the grey areas where we service just beyond the fibre footprint with fixed wireless. And that's about 15% by geography, or 4% by the number of premises. And then beyond that, of course, we use satellite. Satellite covers around about 3 or 4% of the population in terms of premises, but obviously 100% of the geography. It also covers areas like you can see there, Lord Howe Island, Norfolk Island, Christmas Island, Cocos Islands, and all of the coastal islands as well. That's the best technology to be able to provide high-speed broadband services to those areas. We estimate that there's about 200,000 premises that are going to fall inside that satellite footprint. So that's a fairly significant number of premises that need to be serviced by satellite. This is just an example. These maps, by the way, are available on our website. They're interactive, and you can click on them to see, well, firstly how the rollout's going, but also what technology is servicing what areas. And I picked this one, Toowoomba up in Queensland, because it's a good example of where you can see, in this instance, the orange is all served by fibre, and then outside of that you can see the fixed wireless footprint serving some of the regional areas, about 20 kilometres outside some of those fibre serving areas. So this is an important slide. This is a question we get asked a lot of the time. Why don't you just fibre up every premise in the country? And the answer is obviously cost. I mean, you can see there that once you start to get beyond the 93 percentile premises covered with fibre, it starts to asymptote, i.e. it gets very, very expensive to start to fibre the remote regions of the country. So that's where fixed wireless technology comes in. Then you can see that's the most economical technology to use between the last 3 or 4%, and then of course the last 3% of the premises we use satellite, because even wireless, once you get up into the 97 percentile, starts to become extremely expensive as well. It gets to the point where you're sort of building a wireless base station for one house. I mean, you can't, depending on the population densities, that's where satellite, for a relatively fixed cost, by the way, you'll see that line doesn't go up like the rest. That's why we use satellite to service the remaining 3 or 4%. Yeah, it's all to do with the most economical way of doing it, unless of course you do what the Americans do. They're planning to print a $1 trillion coin, I think there was a proposal put up, but I'm not sure we're there yet. But using the 3 technologies, that's obviously why the breakpoints are where they are. It's all to do with the dollars. So moving on to the digital divide, I guess, let's talk about that. It's all about demand, obviously. There's a lot of press at the moment, and there has been for quite some time now, about the skyrocketing amount of data that people are wanting to download over the internet. 10.8 million people go online at least once a day. 421 terabytes of data were downloaded last year. That's an increase of 52%. So these are not small increases. This is not a gentle ramp. This is a massive increase in the amount of data that people are wanting to download. So this is all bringing about a fundamental change in the way everybody lives and the way we use the internet. The Nielsen Online Consumer Report shows that now we are online for more hours of the day than we spend watching TV. At the moment, that's about 22 hours a day. So you can see that. I mean, that's a massive change, certainly from when I was growing up. It was the other way around, of course. So the online experience is obviously becoming richer as well, and you can see the increasing amount of data associated with the resolution type. So I've just got a couple of examples here with like your standard definition LCD TVs or whatever, the amount of data that they use at 900 megabits, moving up through your high definition. It's interesting to see the new iPads now have higher resolutions than the high definition TV, and therefore require more data to stream at those resolutions. Moving right up through to the cinematographic experience that has the higher resolutions there, Ultra HD at 8392 by 4320. Got a while to go before the human. Ultimately, there is a limit between the clarity that we need, the human eye can perceive. But we've got a while to go before we get there. But the internet is everywhere, obviously. It used to be that you would sort of, go into the study or the bedroom and you'd log on and you'd do your email or whatever, and then you'd log off, and that'd be, your internet experience. But obviously that's not the way we use the internet today. It's a more natural and integrated part of everyone's life, and we're using more devices as well to access the internet. And in a home, and I think about my place even with 2 teenage daughters, everybody's on the internet at the same time. It's not just someone using the computer in the corner anymore. We're all using our iPhones, our iPads. If you think about the number of devices in a home that are connected to the internet, I did a quick count last night. I think we got up to about 13 or 14. When you think about the TVs, the Samsung Smart TV, I've got 2 of those. They're both connected to the internet, and the Sonos sound system. And when I walk in, obviously my iPhone switches to use the Wi-Fi router, and so do my teenage girls, and so does my wife. And so, when you add them all up, there's about 13 or 14 devices all using the internet at the same time. So this is all obviously adding to the increased demand for capacity over the internet and the capacity of the network. One thing also is that it's important to understand that when I talk about the iPads and iPhones all being connected wirelessly, it's wrong to assume that that's all data that they're downloading over the mobile wireless or your 3G network. Most data downloaded to those tablet-type devices comes over fixed networks. We're all using our wireless routers or whatever in our houses. That's where the majority of the data on those devices is downloaded to. We all try and avoid the expensive use of the mobile data, and every telecommunications company around the world is trying to offload data as quickly as they can off their wireless networks onto terrestrial networks to free up capacity on the wireless networks. So all this means is that there's more of us going online all the time. There's more devices being used to access the internet. There's more ways that we're accessing the internet, and the content is getting richer and richer and richer, and all this is leading to a huge increase in the amount of data that we need to be able to service. And that's why, of course, we need to be able to build a new network that caters for the demands of the future, not build a network that just deals with the quantities of today. And that includes the satellite, the part of the NBN as well. So that's where I want to talk now about the satellites. I mean, we need to, this is why obviously we need to build our own satellites to deal with this huge increase in demand for data and the capacity of the satellite network we'll need to have. When we've done our corporate plan, of course, this IBIS data that we've showing you here, the graph, we've used lots of sources to try and predict out to 2031 what the internet usage is going to be, what the demand for data is. But this is a good indicator to indicate that the ramp up is terrifically steep. I think that's the whole point there. So just as terrestrial network isn't good enough to meet the demands of the future and needs upgrading, neither is our current satellite solution good enough to meet the hugely increasing demands of the future as well. What we've done, it takes a few years to build satellites, I guess you realise that. 3 or so, or maybe more, and if you take into account the procurement process that we've just been through for the last 2 and a bit years, it all adds up. But in the interim, what we've done is literally brought what we call our interim service to the market. And what we've done there, to be able to do that, is we've leased capacity of existing satellites. We've leased the lion's share of the usable capacity over Australia for broadband purposes off Optus and IP Star. I heard David talk about Tycom before. We're using the Tycom 4 satellite for that purpose. And we've upgraded the infrastructure at their ground stations, and we've brought the Galat Sky H2 modem to the market as well, so that we can now offer a 6 meg 1 product that's very, very reliable and has a decent throughput and capacity as well, the minimum that we need. And I use the term usable capacity because it's no use having a lot of capacity in areas over the continent where no one is. So we need the capacity to be specifically laid down, and I'll talk about that when I talk about our next generation design there as well. We know there are capacity limitations with our interim solution there on the left. As I say, we've leased the lion's share of the capacity from Optus and IP Star, but we know that we're not going to have enough capacity to meet the huge demand that I just went through before, but also, and how that translates through to the monthly plans, the gigabyte limits that people have on their monthly plans, and the number of end users that we can service. You see there, I've got the third dot point there is we've got enough capacity to serve about 48,000 users. Using a measure that we, in the telecommunications, when you're designing networks, called the mean busy hour throughput. So this is a statistical measure. It comes out of Erlang theory and everything else. It's not actual speed that we'd expect a user to experience, but nevertheless, it's what we use when we're designing the capacity of the network to understand how many servers, how many end users we can service, how much capacity we have to be able to do that, and what sort of experience those end users are going to have. To service what we think are going to be about 200,000 end users in the long-term satellite solution, we need about 90 or more gigabits per second of capacity. So that is a huge increase in the capacity available today to what we need for tomorrow. And that is why, of course, we need to build our own Ka-band satellites to be able to provide that dedicated capacity in the areas, in the regions that it needs to be laid down. And this is all brought about because the Ka-band spectrum has now been relatively newly available for this purpose. The spectrum between 26 and 40 gigahertz, or that's the Ka band anyway. And not only from a regulatory point of view has it been made available for this purpose, but at those sort of high frequencies there's more bandwidth available. And we use frequency reuse techniques to be able to liberate even more capacity from that available spectrum as well. But we call them spot beams because you can see that they resemble, rather than, if you look at the beams on the left, they're very broad national beams. The beams on the right are very focused beams. Each one of those beams, the blue ones and the red ones, they're different diameter beams. Obviously, they come off different antennas off the spacecraft. But they each have very dedicated and specific capacity. We use the frequency very frugally, the frequency that we have available, and we need to break that up and use the capacity that frequency allows us, and lay that down very specifically. So each one of those spot beams has a very specifically designed capacity. But overall, the aggregate capacity, both the uplink and the downlink, is about 90 gigabits per second. Actually, we're optimising that. We're going through a process now with Space Systems Loral, who are manufacturing the satellites, to optimise that capacity even further. But that'll allow us to bring much higher speeds to the market. Again, the basic product will be 12 megabits per second, 1 megabit up. And that's the basic product across all of the technology types. As I mentioned before, that basic product is sold at the same price regardless of what technology is delivering it. So that's important when we talk about closing the digital divide. But also, obviously, we're exploring how we can get higher speeds as well. But capacity is the main. If I can leave you with one thought for the evening, it's really about capacity. Speeds are one thing, but capacity is the other thing, and we really need to have a network that can deal with the capacities of the future, and that's why we need to build these two Ka-band satellites with that sort of capacity. This slide goes to show that even with our interim service, it's a vast improvement measured by real customer experience. Whereas before, on the old ABG or 3G and dial-up sort of technologies, regional Australians were, maybe 43% of them were satisfied or very satisfied. Now, with the interim service, where we've got a customer satisfaction of 82%, which is pretty good. considering the time we had to bring it to market and the capacity and other network elements that we've been able to use to do that. And a lot of credit obviously goes to Optus, who are our managed service provider for the interim service. We know we've got a bit of a ways to go to get that to 100%, and we are working on that, and we really want to improve the customer satisfaction. But I think this is a key point, again, in terms of talking about closing the digital divide, is having some quantitative data to assess how we're going in doing that job. So apologies if this slide looks a little bit busy, but that's because we are going to be pretty busy over the next 3 years to build the satellite solution. So apart from the satellites, spacecraft that are actually being built in Palo Alto now at Space Systems Loral, our supplier for those. There's a good-looking gentleman in front of a spacecraft there, very similar to the one that'll be that ours will look like in terms of size. And obviously building them and then launching in 2015 the first satellite, currently called NBNCo 1A. Not very inspiring, but that's the engineering term at the moment. So in parallel with that, we've obviously got to coordinate with other operators, the use of the spectrum, and that's a process obviously that we have to go through with the local regulators and the International Telecommunications Union, and we're going very well through that process at the moment. We also have to build 10 ground stations across the country, each with 13.5 metre dishes there, a couple of those, except at our TT&C sites where we'll have another couple of antennas obviously to control the spacecraft as well. So that's a huge undertaking to get that all built in the next 12 to 14 months. We've actually got Earth being moved at Burke as we speak. It's one of the first Earth stations that we're building up in northern New South Wales. So we've got to build all the Earth stations. We've got also our supplier Viasat, who's designing and building all the Earth station infrastructure, the baseband equipment, the RF equipment, and the antennas themselves that'll go on the roofs of people's homes. We have to develop some new technology there in the modems. They're 4-port modems, so that we can have multiple RSPs servicing any premise at one time, and obviously high speeds and robust and low power consumption. I mean, I think we heard David talk about, in Japan, certainly in Australia, there's a lot of end users out there who want to use solar power to use satellite services from as well. A lot of the properties do use solar power for these sorts of things, and so we want to try and keep the power consumption as low as we can, as well as have enough power though to close the link budgets to be able to get the throughputs and the speeds that we want as well. And then of course we have to integrate that into the rest of the NBN. So we have to integrate the satellite component of the National Broadband Network and the ground stations into the transit network and into our IT systems as well. But the good news is so that's the size of the program, the nature of the scope of the program that I'm managing at NBNCo. But the good news is that so far we are on track, we are on budget to launch our first satellite in around about March or thereabouts of 2015. So in summary, I guess, just wrapping up in terms of addressing the digital divide, we're using a mix of technologies to serve regional Australians, the fibre, the fixed wireless and the satellites. We're using uniform national pricing to ensure that people in the country pay the same for the same service that people in the metro areas pay. We're maximising the satellite capacity to help ensure that people in the country can enjoy the same sorts of services and applications that people in metro areas enjoy. And we're connecting people to the internet who otherwise wouldn't have, or they'd have very poor or extremely expensive internet connectivity. So that's my part of the presentation. That's what NBNCo is doing to address the digital divide. Thank you very much.
Now we'll hear from Nick Leake. So he is currently the Director for Optus's Satellite Marketing Team and Program Director for delivery of the Optus NBNCo first release satellite service that we just heard about. He focuses on developing satellite services to rural and remote areas of Australia and offshore. His career began in 1978 with a Royal Air Force engineering apprenticeship, and he has since made substantial achievements working in the satellite and communications industries in Europe with Mercury Communications and Hughes Network Systems before moving to the Asia Pacific region in 2000. His thorough knowledge of the satellite industry, from manufacture to service provision in broadcast, VSAT and mobile satellite communications, enables Optus to provide a range of leading-edge solutions throughout Australia. He spent time managing the Singtel fixed satellite marketing team that gave him good insight and experience into the Asia Pacific region. In 2007, along with his satellite marketing role, Nick took marketing responsibility for Optus wholesale terrestrial products, which included submarine cable systems, IP transit, transmission voice and DSL, both business grade and consumer. A key objective was the development of product sets ready for the NBNCo fibre and wireless rollout. From October 2009 to March 2011, Nick was acting VP of Optus wholesale and satellite marketing teams, which gave him insight into Optus mobile products and services, including postpaid and prepaid voice and mobile broadband. Since March 2011, Nick has refocused on the satellite business with the introduction of a new broadcast platform, Aurora Digital, that carries the new free-to-air VAST. I always want to say VSAT, I'm sorry, but it's VAST. That's the Viewer Access Satellite Television Service, the NBN FRSS service, new mobile data services including Inmarsat international IP data services and corporate VSAT services including 3G mobile backhaul services, SatZone. Please welcome Nick.
Good evening, ladies and gentlemen. I'm last on, so I can see some tired eyes. So, being marketing, I'll probably wake a few of you up. I was a bit worried to learn that Matt was a black belt in something, because I tend to be a bit controversial about certain topics. So I'll apologise before I start, Matt. No, I was kind of sat at home thinking, I've got two guys on the panel. They're both involved in the current satellite buzzword called KA, and here I am as a KU band satellite operator providing my traditional video, which accounts for about 80% of my business. So what can I talk about when I've got all this KA band capacity coming on my doorstep? So I'm going to challenge you young brains a bit later on, because at the back end of my presentation I just want to discuss the merits of KU versus KA. And then you guys can go off and write a thesis on it and prove me right. But we haven't got there yet, or not. So from our perspective, the satellites are there, they're broadcast satellites, but I wanted to focus on our corporate business, which is a bit like NewSat, but using our own KU capacity. So I'll briefly talk about Optus satellite. I don't want to spend too much time on there. I've got some printouts down there as an Optus satellite fact sheet, so please pick it up. I have got links to some of the things I'm going to talk about, so we'll send soft copies so you can go online and have a look at some of the data I've been looking at, and you guys can look at it as well. We've just done some market research of what the corporate market looks like in the satellite space in Australia. So I'll share some of that with you so you can see what the corporates are really looking for from the satellite services that they want. But basically, Optus in general are obviously an integrated telco. We're not only providing terrestrial service, but you obviously know about having satellite is a real differentiator for Optus, because there's no other telco in Australia that has all that infrastructure. Broad range of services, as I said. Our actual footprints are really focused on Australia and New Zealand. If we want international capacity, so a lot of government customers, a lot of multinational companies that want to get out of Australia, we buy capacity like David's other satellite operators like Intelsat and NewSat, because they own us. So you can see we've got a range of satellites in the orbital arts. The main Earth stations that we have are Lockridge in Perth, that's an international gateway satellites, and Belrose and Oxford Falls coast. This is our launch history, so 25 years of launching satellites, and like NBN, we've come up with some good names. So our next satellite is Optus 10, but that'll be our 10th satellite that we're going to launch. Very interesting. Optus 10 is not designed to be a commercial satellite. It's not being launched to generate any additional revenue. We've actually got to a size in Optus carrying the likes of the Foxtel, the free-to-air services, mobile backhaul, consumer VSATs, corporate VSATs, that we felt it was a time that we needed to build in-orbit redundancy. So not only do we have redundancy on the ground with the diverse Earth stations, the fibre optics, etc., but we will have redundancy in the sky. So if we have a major failure, we'll just float that satellite into that satellite orbit and restore your Foxtel, because I can see you're very sporting and you like your movies. You wouldn't want blank screens for a long time. So that's kind of, we heard earlier about risk. And you didn't answer the question very well, sir. So that's so the risk there is that by having an in-orbit spare, you're actually de-risking your business. Just heard it can take 2 to 3 years to build and launch another satellite. You can imagine if we have an in-orbit failure, wait for 3 years for us to build another satellite. They're going to go off and get the capacity somewhere else, and then we're never going to get it back. So services, again, range of services, broadcast, pay TV, free-to-air, both in Australia and New Zealand. Our satellites, that is our core business. That's what pays the wages. The mobile satellite service, we currently on our B3 satellite, which is inclined. We have an L-band payload that runs our mobile sat services across Australia. That's got an end of life around 2015. Hence, we're looking at BGAN, which is Inmarsat, as a replacement product for that particular service. VSAT, both consumer and corporate, and I can go through the product set there, and consultant services. So we've done over 80 launch assists with Belrose. So when they come over here, we take control of them and make sure the satellites get to where they're supposed to go. And we do a lot of professional services with defence. C1, if you don't know, is a hybrid commercial satellite. So we manage the payload for defence on the C1 satellite. So broadly, the products across Optus satellite, video and radio. I mean, you can read the slide to see what we actually provide. On the voice and data, we have a range of products that run through mobility. So, like with the NewSat picture, we have what we call a Sat Voyager, where we put VSATs on a trailer, response for disasters, or in greenfield mining construction sites, you're not going to get a toaster service in there very quickly, so you roll in a trailer with 2 to 20 megabits full duplex on there so that they can get the service running. Again, we do 3G backhaul now for our own network, so we've commercialised that product. So again, if you want the FIFOs, the fly-in, fly-outs that go from Sydney over to the mining sites in Perth, they want their mobile to work on the mining site. So by putting in a satellite backhaul with a 3G base station, they've got East Coast. Go into the mobile solutions, so we've got some new products that we're launching there for Skype type applications. Media people going out to first response, like David alluded to. Oh, it's small data packets, so it's monitoring and control. So if I want to monitor the flow of, say, water down a pipe, I've got a little monitor there that just tells you how full it is, and it's very small packets, so it doesn't need a lot of bandwidth at all. It's a bit like your ATM machine or your cash card. Yeah, very small pieces of data, and you can run multiple terminals with very small pieces. And it is a growing area of pipelines and in mining. Big thing, health and safety. They want to be able to monitor every vehicle and sometimes every person that's working on that mine for health and safety reasons. So these are a couple of the latest products that I alluded to. The Sat Zone, which is a 3G backhaul product that you can just roll out to any area where there's no mobile coverage. We have commercialized this. Our network people actually use product as well for our mobile network backup. So with the floods in Queensland, we were the first telco to get the mobile services back up and running because we use products. And the BGAN terminal from NewSat is a more mobile data product that can do up to 444 plus IP streaming video. I'm not going to touch too much on this because I think Matt's spoken about it, but again, we were selected as a managed service provider, so we're managing that network for Matt until he can launch his satellites and then migrate across onto the Ka band satellites. VAST, not the VSAT service, that's a brilliant piece of marketing there. Some of you that have been around a while, we had the old Aurora system that was basically for remote area broadcasting. About 2 years ago, we were awarded the contract for the regional broadcasters as well as the remote broadcasters to roll out a bouquet of services, high definition and standard definition services in national broadcasters like ABC and SBS. So the difference between Aurora and Aurora Digital is you've got high def services, you've got ABC. Trying to bridge that digital divide where if you've got your Yagi on your roof and you've got a digital signal, you've got this new channels that you can now get from a free-to-air perspective. So we've replicated that on the satellite. The reason for that is the government are after their digital dividend. So if you've been following the press recently, Mr. Conroy's put a very high dollar per megahertz on the capacity that's going to be freed up by closing down the analog transmitters. And the last transmitter is going to be shut down in WA in December this year. So by that time, everybody has to move off the old Aurora system onto the Aurora. Using latest technology. So again, if some people here remember the old BMAC days, 1 channel per transponder under the MPEG-2 DVB, old Aurora platform, maybe 12 channels per transponder. But now with MPEG-4 DVB-S2, we now are jamming more channels in with a trade-off between what you need for high def compared to standard. So I just want to go through the corporate landscape for satellite communications. 2012, we're looking at about $190 odd million. So there's a lot of revenue to be earned by focusing on the corporate markets. I see from an Optus perspective that with the onset of NBN, the consumer market that we've been very prevalent in through ABG will disappear. So we then have to focus on what we can do in the corporate space. And in the corporate space, they tend to want higher bandwidth, higher availability, disaster recovery type services. So it's a key segment where Optus believes that it can still play a role. Main segments, so again, mining construction, like most of the economic climate, is actually being driven through those 2 main areas. So they want data connectivity to mine sites, and they want big bandwidth. They don't only want to run mobile, they want to run high Wi-Fi networks across the mines, and they need bandwidth to get there. If they can't get fibre in there, they've got to use satellite backhaul. Different segments, different drivers, but again, most of it's data transfer, use of VPN, VoIP, those types of things. But the interesting thing, that's from a corporate perspective. And the bandwidth from a corporate perspective is used from, say, 8 till 8. After that, you've got the guys, the FIFOs that are out there in the cabins. They want to get on their iPad, they want to do some streaming, they want to get pretty good utilization of your capacity, corporate during the day, consumer. And capacity, you've got a TDMA versus SCPC. You can see it's reasonably the same, with the SCPC moving more up the scale in terms of full duplex type services. And we actually think that over the next, as Matt alluded to, that there will be more requirement for corporates to get more bandwidth, to run more bandwidth-hungry applications. Anyway, as in the terrestrial space, like I said, there's going to be more bandwidth requirements. They're also looking for high availability and run basic critical applications, disaster recovery, etc., etc. Where are we going to get the capacity from? So, what I wanted to touch on now, is something for you guys to take on board. So, and the key thing is, not all frequency bands are created equal. So you've got the high power Ka band satellites. You actually have, and they call them HTS, high throughput satellites. You also have high throughput Ku band satellites. And there's a whole bunch of technical engineering details that you guys have got to get into your head, because which is the most economic? From a corporate perspective, they want not only a reasonable price for the capacity, but they want reliability. So as you move into a Ka band frequency, you're going to suffer more from rain fade, so there's propagation issues. So all of the beam, you can concentrate higher power to that particular dish, but then you lose your coverage. There's a whole bunch of different parameters that you have to take into account when you need to calculate which frequency band is best for whatever market segment. I have a paper here that you guys can grab a hold of. There's a paper that's just come out, a white paper from Harris Caprock. Harris Caprock are a global company. They buy more capacity as a retail service provider than any other company. And they have done this study basically to try and understand, going forward, with the hype of the industry being Ka, what is good for my customers? What's going to give me a high service level, high network availability, and give me, bang for my buck, basically. So all I want to do is to generate discussion, because in this type of industry, in any industry, we need to have a debate. I haven't been in engineering for years, so I'm more marketing now, so you engineers are going to have to get hold of this and run with it and decide what you guys think. And I'd like to see some more theses and papers done on it. But basically, we saw IP Star. So IP Stars not only covers Australia, it covers the rest of Asia. And it's a 40 gig satellite. It is high throughput Ku, primarily focused on delivering broadband IP. You then have KA-SAT, which is a Eutelsat satellite that's going up in Europe. Again, that's a 70 gig satellite. So again, it's all spot beam. And then you have little old Optus, 500 megahertz. But it does what it needs to do. It provides video services. So it's point to multi-point. It covers everything. It can multicast. It can broadcast, which is something that some of these spot beam satellites can't do. So what Harris Caprock did, they basically compared a normal Ku Hemi, which is what Optus has got. They looked at the Ku spot, the Ku small spot, the Ku large spot, and then a Ku spot with backup. So you can read through that. So they did the analysis about coverage, flexibility. So where they were coming from, they used multiple satellites. So if they're on a Ku certain satellite and there's a problem with that satellite, they can easily use it to another Ku, because Ku is pretty dominant in the areas that they play. And at some stage, like, in 10 years' time, Ka might be the dominant. But we're just saying, in the current climate, you need to take and evaluate what is the best capacity for you. Cost savings. So in the consumer space where you can really generate volume, you can get the price down to $600 for an indoor unit, a VSAT, and a radio. When you get into the corporate, where they want higher speeds, they want better availability, the terminals are a lot more expensive, but in Ku, because they've been around for years, they're a lot cheaper than a Ka. And it all comes down to even the earth station infrastructure. I saw Matt's probably got a massive bill for building Ka earth station infrastructure, looking at the satellites, because they have to be a lot sharper. They have to be a lot more engineered to actually get the throughput they're looking for. So they've done their study. Ku band satellites have a lower price. Now when you look at the sheet, it has a look at satellites operating in 3 different environments: a normal environment, an arid environment, and a rain environment. So then you can see the percentage of availability versus the cost of the throughput. And then the equipment, as I just touched on, can be less expensive in a consumer space, because you've got the likes of Hughes and Viasat and Eutelsat all driving volumes into those large markets. And when you're selling, I think Hughes announced they've just sold their just shipped their 3 millionth VSAT terminal. So in any consumer game, volume drives costs down. In corporate space, you've got to have a certain level of quality there, both link budget and pricing. So just to quickly sum up and give you lots of food for thought, from an Optus perspective, we think our KU band capacity will still have a life after NBN launch their satellites, and we're going to concentrate on our corporate space because we believe we can provide higher full duplex type services, so 10 meg, 10 meg, 20 meg, 20 meg across our satellites. High throughput spot beam technologies will provide high performance communication well into the future, and I think we will actually complement that. The success there's industrial grade equipment. We need the performance. I mean, Matt's going to put in a 4-port to get all that type into the consumer, but I think running VPNs across the satellite link, other types of applications, running SAT, Citrix, all those types of corporate-based product in the market, and I think that's where we're going to be playing. So, from my perspective, at the end, the debate continues. It's pretty fresh off the press. There's an article that's been written by Intelsat in one of the magazines as well, but I've put a link on for you. So have a look at it, do your research, make your own judgment, and let's have an industry debate about it. Thank you.
Okay, we're going to have questions for 15 minutes.
Good evening, my name is Advait Kulkarni. I'm with the university program that we're doing right now. Throughout the program, we've been talking, discussing, brainstorming a lot about problems like problems of space sustainability, basically some like debris problems and space being a limited resource. So my question is twofold to all the panel members. My first question is, what is your take on collaboration with other companies or other telco providers or other ventures who are trying to do the same thing that you are trying to achieve? And my second part of the question is, what is your take on debris mitigation, mainly your steps pre-launch and also your plans of deorbiting the satellites when they're done with their life cycle? Thanks.
In terms of joint venture cooperation, I think I'll start with that one. From NewSat's perspective, we're already doing that. We've announced that successful relationship with NewSat of Malaysia. We are working closely with NewSat in relation to our Jabiru 1 program. NewSat will have a KU-band payload on that satellite for their use for direct-to-home services in India and Malaysia. In turn, we are also working closely with them for additional capacity over Australia on what we are calling the Jabiru 2 satellite, which is actually in NewSat 3B. They will use that, building that satellite at the moment at Astrium. That will launch later this year. So we're working, the two companies are working very closely together in cooperation. And I think if you look over the whole of industry, you'll see an increasing tendency of operators to cooperate. Back in my past at PanAmSat, we worked very closely with JSAT over the United States. We put the Horizons 1 satellite up together, where Japan had the KU-band orbital rights at a particular location over the US. PanAmSat had the C-band rights, and we had a requirement to replace an old 24 C-band transponder satellite. It was one of the old spinners from Boeing. The economics of replacing a 24 transponder satellite are not great. It's very difficult to get that market to add up. And we had additional requirements for additional KU spectrum over the US. And as we've talked about today in the sessions, spectrum is really the foundation of our business. So JSAT and PanAmSat got together and built one satellite. We owned outright the C-band bus, C-band payload, and we shared the KU payload between the two companies and jointly marketed it. So that was, I think, a very successful example, the most early examples of cooperation, two flags in space on one launch vehicle, one satellite. In terms of debris mitigation, obviously we have to sign up to the requirements of the Australian government with respect to debris mitigation. There are requirements imposed by the UN on all signatories in terms of deorbiting altitude, the 300 kilometre deorbit altitude above geostationary orbit, and inerting the satellite after that, so there's no risk of explosion or damage after the satellites have been deorbited and put to rest. Does that answer the question?
Okay. Well, starting with that one first, obviously we'll be subject to the, having to comply with the same requirements of and the local regulator in terms of what we do with the satellites beyond their 15 years of use life. Trying to remember the core of your question in relation to NBN. I guess in the first instance, obviously with the first release or our interim satellite solution, we've obviously partnered with Optus in terms of being our managed service provider so that we can get that product to market as quickly as we could. Optus have a lot of skills and capability and infrastructure in place that we can leverage quickly. In terms of capacity then, we're able to supplement that quickly with purchasing or leasing capacity off IP Star. But for the long term, it's a different equation altogether. NBNCo is building a broadband network for the long term, So we need to be a wholesale provider of services in our own right. It's difficult with satellite because if you carve out, the satellite part of NBNCo and try and run it as a separate business, it's just impossible. It's not viable. You can't sell what we're selling for $24 a month with the sorts of speeds and capacities that we are. It's only possible as part of the broader NBNCo, as part of the broader national broadband network, because there's obviously internal to NBNCo subsidisations going on there to be able to provide a uniform national wholesale price. So it's a bit tricky, therefore, to be able to form joint ventures and other things if you have to carve out a non-viable part of the business. No one wants to be a partner with you in a loss-making venture. So that's a different equation altogether compared with the first release. So I hope that answers the question.
So we're a regional operator, so our market's Australia. So we've got 4 orbital slots. We're coordinated in FSS in all of them and BSS in some of them. I suppose the only partnership we've had is with Defence. So the C1 was a commercial defence payload, and they operate on that satellite with KA, X-band and UHF. So that's a demonstration of where we've partnered. If we want international capacity, we buy it, and we buy it by having a short-term lease or a long-term lease. You can either have a lease where you're paying OPEX, or you can buy the capacity to the end of life of the satellite and you capitalise it. So it depends how you want to actually do that. And then from getting rid of old satellites, there's plenty of space junk up there, guys. Optus, one of the world's premier TT&C operators, we do get 18 years out of some of our satellites because of the way that we manage the satellites, the way that we fly the satellites. We conserve fuel. And even though B3 end of life is 2015, we reckon we've got enough fuel on there to fly it until about 2022, but it gets a bit wobbly, so there's not many things you can actually operate on there. So we will deorbit that at some stage when we've got enough fuel in it so we can blast it out towards the sun. And that's what good satellite operators do. We have a corporate responsibility to make sure that we don't bump into somebody else's satellite. But it's pretty difficult that far out.
For the NBN satellites, I saw you had the Falcon Heavy as your launch vehicle. Is that the actual case?
Very observant of you too. So obviously I've done that because I can't be specific with where clearly we're not going Falcon, obviously. But we haven't announced who our launch provider will be yet. We will be shortly. So to remain completely neutral, I picked a picture that Wouldn't be biased one way or the other.
Yeah, just a question perhaps for Matt mostly, but there are certain things that satellites can't provide very easily because of the ping time, the amount of time it takes for a signal to get back, and particularly with geostationary. And I'm just wondering how that sort of affects what a satellite user would be able to do versus someone on a fibre.
I'll first go at that. I mean, this is a question that comes up all the time, of course. And you're right. I mean, latency, I think, is the term, the right term for it. And it's the time it takes for a signal to get up to the satellite and back again at 3 by 10 to the 8 metres a second, the speed of light. It's finite. It's true. But there are techniques that you can use, especially with HTTP traffic and that sort of thing. They are very sort of chatty IP protocols. So you can fool those sort of protocols by eliminating a lot of that and using TPEP or these sort of acceleration techniques. And we intend to do that, obviously, with the with Viasat developing the latest that we can in those sort of acceleration protocols and techniques to be able to minimise as best we can the latency effects. Viasat have got a system set up over there in the States that we've had a good look at to try and get a real feel for the user impact of latency. And really, I mean, when you're talking about streaming video and browsing the web and all those sorts of things, it's not really a big deal. I mean, in terms of VoIP even, I think the Australian standards for voice are something like 400 milliseconds before the human ear can detect that there's something funny going on with the response in the telephone call. So when you think about the latency up 36,000 kilometres and back down again, you're talking maybe, well, if it's a single hop, certainly within those sorts of times. It's only if you're sort of doing a double hop that you might exceed that sort of standard. So even with VoIP, the experience is very, very good. So latency doesn't really pose a problem there. So for streaming videos and browsing the web and speaking on the VoIP phone and doing 90% of the stuff that people want to do, it's not going to be a problem. It is, though, a problem, and again, if you're sort of into interactive gaming and all that sort of stuff, that's where it can be a problem, because you're not participating in the game in real time, and I mean, down to the milliseconds that other players globally are, so that you're going to get shot before you've realised that you're in the wrong spot or something like that. I mean, without being frivolous, I mean, those and some of the other real-time applications that do need that split-second response time, yeah, they are affected by satellite, but there's really no alternative. We can't compare the satellite latency certainly with fibre. And then of course, adding to the latency of our network is the latency of the retail service providers network as well. So as I had up there, one of the slides was that we hand off the traffic, the Ethernet traffic at the point of interconnect to the retail service providers, and then they've got their network that the signals have to traverse as well, and they've got their internet gateways and everything else. So that adds a little bit of latency as well. But so I guess the key points are that we are using the absolute latest techniques that people in the industry are familiar with, acceleration protocols, the TPEPs and those sorts of other things that you can do. Traffic class priorities as well. We're going to have 4 traffic classes: quality of service, traffic class 1, 2, 3, 4. So traffic class 1 obviously will get the highest priority of packet switching across the network. And so there are those sorts of techniques that you can use to minimise the effects of latency, but at the end of the day, it's a fact of physics. We can't do anything about the fact that the satellites are in geostationary orbit, and we use geostationary orbit satellites for good reason. But beyond those techniques, there's really nothing we can do about the remaining latency that just has to be there.
add a couple of things. We've been having this argument since day dot when I first introduced the first broadband platform back in 2000. There are the techniques. You can cache. Even the terrestrial networks have to cache now. Southern Cross have just upgraded their cable. They now can get 2.5 terabits of data. But even all the telcos still cache. People like ACMA, carry YouTube and things like that. You just don't want to keep requesting the same data, so you cache it locally. Spoofing, and that's not a drinking game that I used to do in the Air Force, but you're actually spoofing the protocol. You're assuming that you're going to get something and you're hoping that you do. So you're actually not sending so many bits and requests over the satellite, you're just assuming that you get it. So also prefetching. So when you see, if you're on a slow broadband connection and your website populates down slowly, by prefetching you wait a couple of seconds and the whole web page comes up. So what we're doing is we're actually spoofing the consumer. So although you have the delay, you're still getting a very, very good broadband experience that's better than ADSL 1 if somebody's got ADSL 1 or dial-up. So there are techniques, and satellite has always been challenged with the same issue, and we've always found ways of making that experience the best we possibly can.
I think just adding to that though, one of the other things is that we hope that application developers would also develop applications. Like if you browse the web on your mobile, the server detects that it's a mobile device and sends down an appropriate response to the mobile or the tablet or the iPad or whatever device you're using. And so we would hope that application developers would be able to say, oh, okay, this is a satellite connection, be able to detect that, and so not terminate the connection if they haven't received a response within the first 5 milliseconds or something, but to understand that, okay, I need to switch to a slightly different protocol. And that's entirely possible with the application developments that are happening now. So again, yes, there's some latency there and it's unavoidable, but how is it really going to affect the end users? That's what we need to understand.
Unfortunately, we don't have any time more for questions here, but we'd invite you all to come to the reception outside where our experts will be available for another half hour. So if you could please just thank them once again.